Welcome. In this video, I'm going to show you how to sketch this curve using polar coordinates. And we're going to do this with a table. So as you can see, I made a table here. Please take a moment and copy out the same table. And if you're wondering how I pick these points, I pick points I know would work out nicely inside of the sine function. And when I say nicely, I mean something without a radical, something we can, quickly compute in our heads. So please pause your video and copy down this table. All right, now that you've paused your video, you should have copied down this table. So let's go ahead and fill in all these points one at a time. And let's start with theta equals 0. When theta equals 0, r equals 1 plus 2 times, sine of 0, which is just 0, so we end up with 1. Now, when theta equals pi over 6, r equals 1 plus 2 times sine of pi over 6 equals 1 plus 2 times 1/2, and that's 2. At pi over 2, r is equal to 1 plus 2 times sine of pi over 2, so 1 plus 2, and we get 3. Okay, so now that you got the hang of this, please keep going. Fill in the rest of these rows of this table. So pause your video and try this on your own. Please try filling in all these table values. All right, so hopefully now that you paused your video, you had a chance, and you got these values 1, 2, 3, 2, 1, 1, negative 1, 0. And on my own document here, I'm using different colors so that when we graph these, you can tell which corresponding point corresponds to each of these values by the color. And that aside, I don't want to squish my graph in between 1, 2, 3 little circles, so I'm going to say this is r equals 1 here. So this is a circle with radius 1, this is a circle with radius 2, and this is a circle with radius 3. So clearly this would mean this is a circle here with a radius equal to 2.5. All right, so hopefully that's clear. Now let's begin graphing these. When we have an angle at 0, so we're here along the positive x-axis, the radius is equal to 1. So that's this point. Next, when we're at an angle of pi over 6, and an angle of pi over 6, well, what does that look like? Again, here is an angle of pi over 6 in standard position. We would be at a radius of 2, so the point would be here. Okay, and let's go ahead and connect these as best we can. And now let's keep going. So at pi over 2, we need a radius of 3. So we're all the way up on this outermost circle. All right, so there we are. Next one, we are at 5 pi over 6. Our radius is equal to 2. So here is 5 pi over 6. This is the terminal side of this angle, and we need to be at a radius of 2, so that's here. And just continue connecting the dots as you go. When we are at an angle of pi, so the terminal side would lie along this line. The radius is 1. All right, so far so good. Okay, so as we continue, we need to plot the radius given for 7 pi over 6. And I just realized I made an arithmetic mistake right here. 1 plus negative 1 is 0. Excuse me, let me fix that. There we are. So at 7 pi over 6, so the terminal side is on 7 pi over 6. We're at a radius of 0. So go ahead and draw a point at the origin. And let's connect this. Okay, so now let's look at 3 pi over 2. 3 pi over 2 has a terminal side right here. And we're told we want a radius of negative 1. Well, here's a radius of 1. Negative 1 is right here, so draw your point right there. And let's connect this. There we are. Okay, so when the angle has a terminal side ending on 11 pi over 6, the radius is 0, so we want another point at the origin. We're coming right back down here to the origin. So let me put a purple circle here. And to make it clear, This is theta equals 11 pi over 6 right here. And in orange, we have theta equals 7 pi over 6 right here. So when we have an angle of 2 pi is right here along the positive x-axis. That is, it has the terminal side along the positive x-axis. The radius is 1, so we need to be right back here. And I'll go ahead and do a half coloring again and connect this right back. There we are. All right, so now just to demonstrate what we've done, when our angle is 0, we start here and our curve goes along in this direction. And if we go over 2 pi, it will just keep going. It'll go again in this little loop-de-loop fashion. I hope you found this video helpful.